Hello, how to solve this exponential problem? We have n power 3 equals 1 divided by 8. We are solving for all values of n that satisfy this equation. Now, we have 1 here, there is 8. Here is power of 3. I can express this one here as 1 power 3 because 1 power 3 is same as 8 as 1. I can also express this 8 here as 2 power 3 because 2 power 3 is 2 times 2 times 2, which is 8. So this will give us n power 3 equals 1 power 3, which is 1, divided by 2 power 3, which is 8. Now, if you have a power c divided by b power c, this equals a divided by b all to the power of c. So I can apply this right here. I will simply have n power 3 equals 1 divided by 2 to the power of 3. So from here, I can move this over here. I have n power 3, this becomes minus 1 divided by 2 to the power of 3, this equals 0. So at this point, I have power 3, I have power 3 here. So what I'm going to do will be to expand, and we can expand this using this identity. If you have a power 3 minus b power 3, this equals a minus b times a squared plus ab plus b power 2. And in this case, our a equals n and b equals 1 over 2. Let's insert it right here. We are simply going to have a minus b, that is n minus 1 over 2 times a squared, that is n power 2, plus ab, that is n times 1 over 2, plus b squared, that is 1 over 2 to the power of 2, and this equals 0. So from here, I have n minus 1 over 2 times, this is n squared plus n times 1 over 2, this is n over 2, plus 1 power 2, that is 1 divided by 2 power 2, that is 4, and this equals 0. So at this point, we can equate each of these to 0. We have n minus 1 over 2 equals 0. We also have n squared plus n divided by 2 plus 1 over 4 equals 0. Now what we are going to do will be to solve these improved equations. Let's start with this one here. We can have n equals 1 over 2. By simply moving this over here, this is our n1. Now we have this quadratic equation that we are going to solve for other values of n. Now before we solve it, we need to make sure that we find a common LCM. So this over 1, a common LCM here is 4. 4 divided by 1, 4 times n squared, this is 4n squared, plus 4 divided by 2, 2 times n, that is 2n plus 4 divided by 4, 1 times 1, that is 1, and this equals 0. This over 1, we cross multiply. The whole of this will multiply 1, and this will multiply 0. So I have 4n squared plus 2n plus 1 equals 4 times 0, that is 0. So this simply means we have 4n squared plus 2n plus 1 equals 0. So what we are going to do will be to solve this equation. We are going to solve this using the formula method. We have n equals negative b plus or minus square root of b squared minus 4ac divided by 2 times a. So right now, 4 here is equation of n squared, that is our a. This is b, this is c. Our n equals negative b, that is negative 2 plus or minus square root of b squared, that is 2 power 2 minus 4 times 1. That is divided by 2 times a. That is 2 times 1. Okay, a is 4, that is 2 times 4. From here, I have n equals, this is negative 2 plus or minus square root of 2 power 2 4 minus 4 times 4, 16. 16 times 1. Divided by 8. From here, n equals, this is negative 2 plus or minus square root of negative 12 divided by 8. This gives you negative 2 plus or minus. There is minus here. I have square root of negative 1 times square root of 12 divided by 8. From here, n equals, this is negative 2 plus or minus. This will give you I. Square root of 12, I can express it as 4 times 3 divided by 8. From here, I have n equals negative 2 plus or minus I times square root of 4. 2, we have 3 divided by 8. This cancel, this you add 4. Both negative 1 plus or minus I root 3 divided by 4. From here, I have n equals 1 over 4 times negative 1 plus or minus I root 3. So I have two values for n. I have n2 equals 1 over 4 times negative 1 plus I root 3. I have n3 equals 1 over 4 negative 1 minus I root 3. This and this. This added to complex solutions, and we also have one real solution, which is 1 over 2. So the next step we are going to take would be to simply check for this value of n. I have to check, remember n equals 1 over 2. That means you have n power 3 equals 1 over 8. You substitute this for n, you have 1 over 2 to the power of 3 equals 1 over 8. Now, if you have a power a divided by b to the power of c equals a power c divided by b power c. So, applying the same thing here, we have 1 power 3 divided by 2 power 3 equals 1 divided by 8. From here, 1 power 3 is 1 divided by 2 power 3. That's 2 times 2 times 2. That is a, and this equals 1 divided by 8. Left hand side equals right hand side. So that is it, guys. How did we actually solve this? A quick recap. Ensure that you express this in terms of 1, that's 1 power 3. Make sure the exponents are the same. Then we express 8 as 2 power 3. Then we combine this by sharing the common exponents. We form an equation by moving over here. We expand this equation by making use of this identity, this cubic identity. Our a is n, b is 1 over 2. After everything, we had two equations in which we equated each of these expressions to 0. Then from there, we solved the linear equation. We had the first real solution. Then we had this quadratic equation. Before we could solve, we ensured that we find the common LCM. So after finding the common LCM, we then solve it using the formula method. And this actually gave us two complex solutions. And these are the two complex solutions. We have this and also this. So in total, we have 3 different solutions in total. So that is it, guys. Thank you and see you again.